Welcome to SS2 Physics, Term 1, Week 4. Electricity powers modern civilization, from the lights in your home to the mobile phones you use, from the hospitals that treat patients to the factories that manufacture goods. At the heart of electrical circuits lies Ohm's law and the principles of series and parallel connections. By the end of this lesson, you will be able to state Ohm's law, calculate current, voltage, and resistance, analyze series and parallel circuits, and determine total resistance and power dissipation. These skills are tested heavily in WAEC physics. Let us begin. Ohm's law, formulated by George Simon Ohm in 1827, states that the current flowing through a conductor is directly proportional to the voltage across it, provided temperature and other physical conditions remain constant. In formula form, V equals I times R, where V is the voltage, potential difference, in volts, I is the current in amperes, and R is the resistance in ohms, symbol omega. Rearranging, I equals V divided by R, and I equals V divided by I. Resistance is the opposition to the flow of electric current. Good conductors like copper have very low resistance. Insulators like rubber have very high resistance. Resistivity ρ is a material property. I equals ρ times L divided by A, where L is the length of the conductor and A is its cross-sectional area. A longer, thinner wire has higher resistance. Factors affecting resistance, material, resistivity, length, directly proportional, cross-sectional area is inversely proportional, and temperature, for metals, resistance increases with temperature. The ohm is defined as the resistance when a current of 1 ampere flows through a potential difference of 1 volt. VI graphs, for an ohmic conductor, one that obeys Ohm's law, the VI graph is a straight line through the origin. The gradient equals resistance R. In a series circuit, components are connected end-to-end, so the same current flows through all of them. The total resistance is the sum of individual resistances. R total equals R1 plus R2 plus R3. The voltage divides across each resistor in proportion to its resistance. V1 divided by V2 equals R1 divided by R2. The current is the same everywhere. If one component fails, the whole circuit breaks. Example, 3 resistors of 2 ohm, 3 ohm, and 5 ohm are connected in series to a 20 V supply. Total resistance equals 10 ohm. Current equals 20 divided by 10 equals 2 amperes. In a parallel circuit, components are connected across the same 2 points, so they share the same voltage. The total resistance is found from 1 divided by R total equals 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. The total current splits, I total equals I1 plus I2 plus I3. If one component fails, others continue to operate. This is why household wiring uses parallel circuits. Example, 2 resistors of 4 ohm and 12 ohm in parallel. 1 divided by R total equals 1 quarter plus 1/12 equals 3/12 plus 1/12 equals 4/12. R total equals 3 ohm. Note that the total resistance in parallel is always less than the smallest individual resistance. Electrical power is the rate at which electrical energy is converted to other forms. Formula P equals I times V, or P equals I squared times R, or P equals V squared divided by R. Power is measured in watts, W. Energy is measured in joules, J, or kilowatt-hours, kilowatt-hour, for household billing. Example, a 60-watt bulb connected to 240 V supply. Current equals P divided by V equals 60 divided by 240 equals 0.25 amperes. Resistance equals V divided by I equals 240 divided by 0.25 equals 960 ohms. NEPA, PHCN, bills you in kilowatt-hour, kilowatt-hours. 1 kilowatt-hour equals 3.6 times 10 to the power 6 joules. Summary, Ohm's law, V equals IR, series circuits, same current, R total equals sum. Parallel circuits, same voltage, 1 over R total equals sum of reciprocals. Power P equals 4 equals I squared R equals V squared over R. Remember the mnemonics, via a triangle for Ohm's law. Practice the WAEC style problems, finding total resistance, total current, power, and identifying series versus parallel configurations.